Hi, everybody, and welcome back to this fifth meeting of the RENEW18 Open Research Seminar. I am Marco Storni. I'm a postdoctoral fellow in the RENEW18 group based in Brussels. And today it is my great pleasure to introduce our guest speaker, Katherine Dunlop. Katherine is Associate Professor of Philosophy at the University of Texas at Austin. She held, before joining UT Austin, appointments at Brown University and Stanford University. And her work focuses on 18th century views of exact science. She worked extensively on Kant, but also on other figures such as Lambert, Solomon Maimon, and most recently, Émilie Du Châtelet. And today she is discussing with us a draft paper entitled Du Châtelet on the Theory and Use of Pendulums. So Katherine will have 10-15 minutes to present the text, which we've already read, and then we'll open the discussion. So thank you very much again for joining us and for sharing your work in progress with us, and the floor is yours.
Well, thank you for having me. I thought I'd just begin by mentioning, I know it's sort of customary to explain how the work in question fits into a bigger project. And in this case, the bigger project isn't mine. I was asked to contribute to a volume on Du Châtelet on her use of case studies. This is being co-edited by Peter Anstey and Clara Carus, and I think they very correctly identify this as a gap in the literature. So I had this invitation, and I thought, well, she says a lot about pendulums, and I've been trying to pull that together. I think I actually underestimated just how much research had to do with the use of pendulums and how much she discusses when I started. So it's become kind of sprawling. And I thought I'd maybe mention also that I ended up trying to make the material comprehensible even to readers who, like myself, had their science education in the 1980s and 90s in the US, which was really, really lacking. So there could be a lot where you all will read it and say, yes, that's just obvious. So I apologize if that's the case. But that's the background. And at the end of the day, I was hoping we could come away with a not just a comprehensive understanding of how pendulums were used. That's interesting from a historical point of view, but I was hoping maybe also to link it to some of her more interesting philosophical ideas. So I'll just walk you through some of the main points of the paper. Here are my slides. Hopefully you all can see that now. Yes, good. Okay. So the paper really follows along, for the most part, with follows Du Châtelet's own order of exposition, and she's very concerned to discuss how gravity operates and what is its cause. The first part of the discussion just concerns how gravity operates, and one of the main ways in which pendulums first enter is the result that for two pendulums that oscillate in similar arcs, their times of oscillation their periods will be proportional. So historically, this figured as a demonstration that the force of gravity acts in such a way that the spaces traversed will be as the squares of the times and the speeds. Of course, this was something that Galileo found. She describes this in one notable passage as the fact of physics of which we are most sure. And she describes many, well, at least several important experimental procedures that have shown this, many of which don't involve pendulums. So I thought that with regard to this particular result, the fact that you can show it with pendulums isn't really so important for establishing that result. It doesn't really need that support. But it does support thinking of heaviness as the sole cause of pendular oscillation, and that's important because that then licenses the use of pendulums to study heaviness. And then, excuse me, to establish heaviness as the sole cause, Du Châtelet has to rule out these other factors: the tension on the cord, air resistance, friction. I think the most interesting of these is her discussion of the tension on the cord. She argues that, well, she has to accept that as a cause, but she argues that it is what she classifies as a passive cause because it changes direction without imparting any new motion. And then with air resistance and friction, she draws on some empirical results, basically just to argue that their effects are negligible. So that does leave us, if she's right, with heaviness as the sole cause. And again, that's important because we can then use the behavior of the pendulums to understand gravity or heaviness. As far as I can tell, she uses those terms interchangeably. Now, the main way in which experiments with pendulums facilitate the study of gravity is by allowing for measurements of time, and here in two different ways. Historically, first, I think, by allowing us to repeat the same process over a number of periods. Specifically comparing the falls of two bodies, which are different in their material. The idea is that each individual fall takes place in such a short time that we can't really measure the differences between them. However, if we can repeat the falls over and over, then those differences accumulate. So that Galileo is quite explicit that that's his methodology, and Du Châtelet discusses that. And then secondly, by allowing intervals of time to be correlated with spatial lengths, and this solves what you might think of as a conceptual problem in measuring time, which is just that the intervals of time keep on succeeding one another. Each of them, Du Châtelet, I think, is drawing on Locke when she brings out this problem. And for Locke and for Du Châtelet, the problem is that, each particular interval of time perishes before the next comes into being. So the previous one isn't around anymore to directly compare with the later one. So this leads both Du Châtelet and Locke to argue that what we really need is some kind of periodic process, and in the best case, a process that associates, again, the interval of time with a distance in space, because the spatial distances do stick around to be compared. So as Du Châtelet is discussing the use of pendulums to study gravity, there are three main results which show us how gravity operates. So there's Galileo's result, Newton's result, that the force that makes the bodies fall is proportional just to the masses of the bodies. So that's the case where comparing different kinds of bodies is relevant. So she discusses those experiments. And then finally, so I realized as I was putting these slides together that I would be discussing this material out loud with speakers of Flemish and possibly even Dutch, and you'll just have to excuse me because I just can't pronounce this, but Huygens' determination of the distance fallen in the first second. And Du Châtelet recapitulates the calculations based partly on the mathematics of the cycloidal pendulum, and then partly just on measurement, by which we find this distance to be approximately 15 Paris feet. And she notices, so here's a very explicit statement of how pendulums are useful. Again, the time of fall is very short. The distances are accordingly very short, but by using pendulums, we can, as it were, magnify these differences in times. Then Du Châtelet goes on to point out that if we were to use Huygens' procedure at all latitudes, three things would have to be the case. First of all, heaviness would have to be equal in all regions of the Earth. Secondly, the space fallen in the first second would have to be the same regardless of the distance of fall. Thirdly, no perceptible effect from air resistance. And then she explains why these conditions fail to hold to various extents. So for us, the most interesting case is the variation in surface gravity. And as I expect you all probably already know, sorry, I just, whoops, it enlarged and it went forward. Okay. This was shown not to be the case in the first place by Jean Richer trying to make astronomical observations at Cayenne Island. It's interesting, I didn't put this in the slide. Du Châtelet describes Richer's observations as incontrovertible in a few places. And those are the only observations that she really singles out. And I think that is probably because, at least by the third edition of the Principia, those were the only observations that Newton was willing to take for granted. So once this was found, of course, this scuttled the idea that you could use the seconds pendulum as a universal measure of length. And Huygens was perfectly well aware of this. Huygens and Newton then both developed theories of the shape of the Earth, which would explain these variations in surface gravity. The theories are different. Newton's is based on universal attraction among the parts of the Earth, which Huygens rejected. Huygens just assumes centrifugal force and then draws on principles about what it takes for the Earth to be in equilibrium. Newton's theory predicts a greater amount of flattening than Huygens. Now, I circulated one draft of this paper, and part of the reaction that I got was some surprise that Du Châtelet doesn't make more of the measurements in Lapland in the 1730s by Maupertuis, Clairaut, and their group, which show that the Earth does protrude towards the equator. And that this was a big deal in the French context, as you all probably already know, of course, because the dominant theory in France was based on the surveying results by the Cassinis. And according to those results, the Earth actually bulges towards the poles. So in histories of this period, it's often suggested that the qualitative result that the Earth actually does protrude towards the equator rather than the poles, that rather conclusively showed that Newton's theory was right. And what it does show is that the Newton's Huygens theories, one of those has to be correct as opposed to the Cassini's theory. But and so I'm sorry. So again, there's some discussions of this period sort of run with the idea that this was empirical verification that Newton's theory was right. And then Du Châtelet doesn't really make a big deal of it. That much is right. And then the thought is she just underestimating the empirical support for Newton's theory? Which is something that it wouldn't perhaps be so surprising if she did. Because at the end of the day, Du Châtelet is not willing to accept Newton's theory because she thinks it violates the principle of sufficient reason. And from that point of view, the empirical evidence is just really not going to decide the question. And there is certainly something to that. However, knowing that that's Du Châtelet's background view, I think that she's really impressively sensitive to the empirical questions. And her discussion brings out why this issue of the amount of flattening was important and remained important even after the Cassini theory was refuted. So I am drawing quite heavily on the work of George E. Smith, and in particular, he has a beautiful paper on Du Châtelet's commentary on the Principia. Du Châtelet prepared a commentary which was appended to her own translation of the Principia, published a bit later than her Foundations of Physics. And there's a lot of really interesting material in there, and I think George does a great deal to bring its interest to light. On his telling, the opposition to the Principia on the continent was mainly philosophical up until the very early 1730s, with the exception of Huygens. Huygens accepted universal attraction at a large scale, but rejected universal attraction among the parts of bodies. And Huygens himself drew attention to the different views of the shape of the Earth as something that could, in fact, be empirically measured. So this was a very early step towards framing the correctness of universal gravitation as an empirical question or issue. And this came to broader attention when Maupertuis really highlighted this question and the possibility of empirically resolving it in his 1732 monograph on the figures of celestial bodies. So that was 1732, and then we have the Lapland expeditions. Du Châtelet, in her commentary on the Principia, but even also in Foundations of Physics, Du Châtelet makes clear that this question of the extent of the flattening remains unsettled. And then in the commentary, she brings out how the Lapland measurements actually pose something of a problem for Newton's theory, based on Clairaut's subsequent mathematical work. According to Clairaut's reasoning, the measured amount of flattening is actually greater than is even compatible with Newton's principles. So this is a way in which the Lapland results obviously do not show Newton's theory to be correct. It's something that seems to have kind of dropped out of the historical consciousness, at least again, based on all of the histories that just say, oh, the Lapland expedition showed Newton's theory was correct, but Du Châtelet was quite sensitive to it. Now, as far as how this all links into Du Châtelet's philosophical views, from the point of view of history of philosophy of science, Du Châtelet is really notable for her discussion of hypotheses. She is willing to advocate their use, although with certain precautions, and her discussion just stands out as really quite novel. One claim that she makes that, and her theory of, her discussion of hypotheses has received a fair bit of attention, but one claim that she makes that I think has not really gotten a lot of attention is that hypotheses are a great means of invention. And I take it here that invention suggests creativity, invention, bringing something new into place, as opposed to discovery. To say that they're a great means to discovery would really maybe not be such an interesting claim. And the idea that they are a means to invention is interesting. It's hard to see from a couple of perspectives. Just the way that we've continued to think about hypotheses going on into the 20th century, it's been recognized that the formation of hypotheses in the first place requires creativity or invention. To that extent, the method presupposes invention, but it's hard to see how the use of hypotheses then leads to invention after the stage of, formulating the hypotheses in the first place. More of the feedback that I got on this early draft of the paper is one can't really draw on Hempel in explicating Du Châtelet, because what she thinks of as the use of hypotheses is not what he calls hypothetical deductive method, and that's a completely fair point. But I think that from her own perspective, or in her own context, it's still hard to see how the use of hypotheses really facilitates invention, or really, I mean, I guess why that would be a good thing. Because by her lights, it seems that what we really should worry about is the overuse of invention, and the worry that with introducing hypotheses, we're introducing, sorry, I didn't put the whole passage on here, but introducing monsters which we will never be able to tell apart from realities. So maybe it does involve creativity, but that's not purposeful. So the problem then is to understand how it is that the use of hypotheses facilitates invention, and then how that's purposeful for science. And I wanted to explicate that in terms of her claim that hypotheses give the idea of new and very useful experiments. I don't think that by itself really clears up the picture, because certainly an experiment can be useful in that it decides whatever particular hypothesis gave rise to that experiment. But it's hard to see how that is a great and lasting contribution to science. And then I thought that maybe the way to see that is to notice that Du Châtelet very consistently describes as, or refers to as, experiments, procedures that we might ordinarily think of as measuring procedures. And when we take that into account, we can see how one of these experiments, in this broad sense, does remain useful even after the hypothesis which gives rise to it has been decided. And we have, I think, a nice illustration of that in the use of pendulums. So just the first point is in Newton's scholium following his definitions, he discusses the need to correct apparent solar time, and how the need to correct that has been, in his words, proved, partly by observations of Jupiter satellites, but partly by pendulum experiments. So those experiments and measurements go to show that apparent solar time is not the appropriate measure to use. When measuring time, we should use, for instance, pendulums instead. So there, you can think of there being a supposition in place to the idea that the apparent motion of the sun is regular. We then find that supposition to be false. So this is a context in which there's something like a hypothesis that's being refuted. Now, when it comes to Huygens' proposal to use the second pendulum as a measure of length, that was explicitly a proposal. And it wasn't, as far as I know, actually put into practice, because it was refuted already beforehand by Richet's observations. This is another context in which we have something like a hypothesis. It's the basis for a measurement procedure, and that measurement procedure functions as an experiment testing that hypothesis. And in this case, the hypothesis is defeated, the hypothesis being, again, the assumption that surface gravity is uniform. But the measuring procedure in question remains useful even after the defeat of that hypothesis, because what we then find is that the second pendulum can be used not to measure length, but to measure the local strength of surface gravity. And that's precisely the way in which, in this continental context, empirical evidence was really first brought to bear on Newton's theory of universal attraction. So in this case, the experiment in question does go on to have a quite important role in the subsequent development of science. So that is, I don't want to claim that Du Châtelet explicitly intended her discussion of pendulums to illustrate this point. The material on pendulums, it's sufficient to explain its inclusion just in terms of the overall project of Institution, of getting her French readership up to speed in what's going on in physics. But if we, reading her discussion of hypotheses and thinking, how is that supposed to work? If we're looking for some explanation of that, her discussion of pendulums does serve very nicely to illustrate that point. So that was the idea of the paper, and maybe we can open it up for discussion now.
Thank you very much, Katherine, for this very clear presentation. So we can actually open the floor for discussion, for questions, comments. Perhaps I can start with I have several questions and comments, but I will start off with a very short one, which is perhaps a detail, but more a clarification. At page 8, you will talk about Galileo and his theory of pendulums or his experiments with pendulum. And it struck me that at a certain point, you talk about the fact that certain further results seem to invalidate or to correct Galileo, the certainty, as you put it, of Galileo's result. But that Du Châtelet, although she was aware of these corrections, she still described Galileo's result as the fact of physics of which we are the most sure. So I was a bit puzzled. I don't know if I missed some information, but I was wondering why does she still describes this result as the most sure fact, and if there is an idea of certainty in physics which is particular behind this statement.
Yes, yeah, it's a great question. And there is something genuinely puzzling there, I think. Part of her point, I think, is that the reason that Galileo's result isn't strictly correct for even the cases he's looking at is the diminution of gravity as one moves away from the Earth's surface. But that is something that's going to be empirically really undetectable by these means that she's talking about, because one just cannot measure falls from the heights that it would take. So it retains certainty, at least to the extent that let's see, what's the right way to put this? Insofar as it's possible for us to study this particular phenomenon of terrestrial fall, none of the means available to us to study that are going to show that he's wrong. We find that there has to be this diminution only when we put this in the context of Newton's theory based on celestial observations as well. So it retains its certainty in the sense that, again, in sort of just the terrestrial context, the experiments would always continue to validate it. But no, I think that, oh, and I guess I can say also, when she speaks of it as the fact of which we are most sure, I think she may partly also just be making the point that this proportionality result is a basis for some of these later developments that she's talking about. So to that extent, some of these other theories presuppose it, at least on the assumption that the height of the fall doesn't affect it. But no, I don't know that any of that really quite gets to the bottom of how this can be, on the one hand, not strictly true, and on the other hand, most certain, unless, again, the certainty is really just relativized to what we could know in terrestrial investigations.
Thank you. Thank you very much. I mean, I can go. Oh, Karin, please.
Yeah, okay. Yes, I read your paper with great interest, even though it's not really my area. And one small point that drew my attention was Du Châtelet's criticism of Newton as regards the principle of sufficient reason. Yes, so she brushes his views aside by saying, well, it doesn't satisfy the demand for sufficient reason. But then reading the remainder of your paper, to me, it was not clear what work the PSR does for her. Yes, because evidently your account is focused on experiments, and so maybe it's not relevant to that aspect of her investigations. But I was wondering, maybe also more in general, apart from this specific theme of your paper, whether she herself makes use of the principle of sufficient reason in a convincing manner, even though she also wants to hold on to Newtonian ideas.
Yeah, thank you. Yeah, that's another great question. So I don't see, I do not see her making much use of the principle of sufficient reason in this account of our knowledge of gravity. And partly, again, the aim of the discussion is to introduce her readership to this series of historical developments, and the figures she's discussing are not really using it either. So maybe that's to be expected. But I think that the way in which let me actually also just bring out that to try to pull together both the more philosophical or foundational material in Institution and the discussion in the commentary. In the commentary, I think she's really bracketing her own philosophical views. And that's something that George Smith found as well. So in the commentary, she goes into a lot of material which, yes, by her own lights, really is not relevant. You can't empirically show that Newton's theory is right for just the reason that you're saying. If one tries to put those together, though, if you go back to Institution, where she's discussing the empirical results at a sort of much more general abstract level, what she says in Institution is that she discusses all of these phenomena which the vortex theories do not satisfactorily explain. Newton's theory does give this very nice explanation. And then at the end of that discussion, she says, and this is something that I don't think founded into this draft of this paper of mine, what she says is that perhaps the development and application of Newton's theory has shown that none of the vortex theories so far available are sufficient to explain these phenomena, but that just means that it's up to us to develop a better mechanical theory. In that context, she leaves no doubt that a satisfactory explanation has to be just in terms of matter and motion. It's going to be some version of a vortex theory. I think, by her lights, what we need is a second iteration of a Huygens who will come up with something that improves on the current theories as much as Huygens had improved on Descartes' theory. Now, she doesn't give any indication of what that would look like. And it's sort of held out as the theoretical desideratum. But I think that is maybe the way to put together for her the empirical research with the philosophical unacceptability of universal attraction. This just sort of sets the standard for what a vortex theory is going to have to do.
And so sorry, if I can ask, so what would be the employment of the principle of sufficient reason in this case? A kind of appeal to a more philosophical hypothesis, or sorry, I do not really. Of course, I see the tension, yes, between empirical features and experiments and so on, and more philosophical or speculative hypotheses. But so does she specifically address this in terms of the use of the need to use the PSR? Is it part of her arguments in her work?
Well, in this context, it comes in really just as the decisive objection to Newton's theory. It is what shows us that at the end of the day, we need a mechanical theory. Now, I guess that's compatible with taking Newton's theory on board and carrying out these empirical tests, because again, doing that shows us what ultimately a vortex theory will have to explain. But it doesn't. So I don't think that she does give any positive application of the PSR to explain any of these physical phenomena. I do think there's some appeal to the PSR in her development of the laws of motion, and then in her elaboration of how those laws will get applied in a mathematical framework.
Mm-hmm.
In an earlier paper of mine, I looked at her discussion of the parallelogram law for combining, as we would say, vectors and forces. And perhaps somewhat implicitly, she makes use of the PSR there, and she's drawing on thinkers who made more explicit use of it. So at that foundational level, I guess you could say, of her physics, that the PSR is playing a positive role. But when it comes to saying, oh, gravity works this way rather than that way, I don't really see it playing any application.
Okay. Thank you yes, that's clear. Thank you.
Good.
Well, but perhaps, yeah, Annie, please. Yeah, I will. We can't hear you. Can you turn on your mic?
Thanks a lot, Katherine, for your paper. There's a lot of material, and I want to go to the last part where you connect, let's say, these two parts in Du Châtelet. So her discussion of these irregularities in gravity and her discussion of hypotheses. It's not a point of criticism, but more like I'm still a bit unsure if, let's say, her definition of what a hypothesis is, so you quote it, it's supposed in order to explain what has been observed, and its truth is impossible to demonstrate. And so that's something Du Châtelet puts in her definition of the hypothesis. So they are intended to explain observations, and they are impossible to demonstrate. But you then yourself establish in a way that Du Châtelet's definition ties the hypothesis specifically to explaining observations. And my question is if this was the case for Huygens, or is this just the interpretation, your interpretation of taking, so to say, Huygens' claim that, or Huygens' assumption that gravity would be equal everywhere, and that you can use the pendulum second as a measure for space or for distance. I think there's perhaps, in my view, not enough about Huygens' thought about what his claim is. Does it, in Huygens' view, amount to a hypothesis, or is it just in your interpretation, you're taking it via Du Châtelet that it becomes, so to say, a hypothesis?
Yeah, thank you. No, so I was not intending to give an interpretation of what Huygens was himself doing. And it would be good to have more to say about that. And it's certainly a bit of a stretch by Du Châtelet's own lights, given that the hypothesis is supposed to explain observations. It's certainly a bit of a stretch to speak of the assumption of uniform surface gravity in the context of the horary foot proposal, because you could very well ask, well, what is the observation here that's getting explained? And I guess it seems to me that maybe Du Châtelet would be comfortable with that, because just as she uses experiment in this broad sense to encompass measuring procedures, perhaps observation can be used in a broad sense to encompass some sort of systematic correlation between a use of an instrument and whatever mathematical values we assign on that basis. It is definitely a sort of looser usage. And I haven't actually tracked her usage of the term observation in particular. I do think tracking the term experiment, there are all of these contexts in which she describes as an experiment something that we would otherwise just say, well, hey, that's just a measurement of a length. So the looseness is there in the experiment case. Observation case, that is a good thing for me to go and think some more about. But no, as far as what Huygens himself had in mind, so I keep pronouncing it with kind of a U sound because, but it's more like a kind of a long A sound.
Yeah, Huygens. No, but
Huygens. I can. All right, we'll work on this. Okay. One thing that's actually quite striking is in her discussion of the cycloidal pendulum, there's one level at which the discussion is fairly purely mathematical. The mathematics involves some kinematics, but it is, to that extent, she is following Huygens' own development, which is really quite strictly geometrical. But then there's a point at which she says she is giving the physical reason, and she draws a correlation between certain geometrical elements and the strengths of forces, which is not present in Huygens' own development, at least in the monograph. So I think that, at least in that instance, she is taking something that was, developed in a more mathematical style by Huygens, and perhaps, I mean, it's not as if he wasn't in a position to recognize the physical relevance, but he certainly wasn't bringing it out right there. And that perhaps that is something that we could see her as doing more broadly.
Okay, perhaps a follow-up, because you seem to, well, you said you encounter a lot of cases where she uses the term experiment, but in the time in French it was expérience, and I've worked a bit on Lavoisier, and for example, that's later than Du Châtelet. And the Germans, they translated expérience in Lavoisier by Erfahrung, and the English, they translated it by experiment. And so perhaps there was still some vagueness to the term, that it can mean both experience, someone experienced this in the sense of an observation, or it might not be an experiment in the technical sense, whereas in other places it might be. So perhaps that's also an explanation for your wondering at the variety, perhaps, of her uses of the term.
Yeah, that's a great point. Thank you. And it's something that I had thought of at one stage in writing a paper, but I didn't see how to make much of it. Yeah, it seems, I wonder if by our own lights, one might still want to carve off measurements from the broader class of even observations per se. Measurements are rigorized in a way. Observations are rigorized across the board, but with measurements, there's this special question of whether the mathematical representation that we're coming up with is appropriate given the phenomenon, which is maybe not, not maybe a question with observations that one is willing to leave in more qualitative terms. So there might still be a version of the issue, but yeah, that does make it. I'm trying to come up with the negation of incongruous, and I'm just coming up with congruous, and that's not quite right. But anyway, yes, thank you. That is helpful.
Yes, please, Ovidio. I guess it's a follow-up.
It's not really a follow-up, I think. So if you have anything to follow up, that's okay.
But I mean, I was going to, beforehand he followed up on his own question, say something similar. I mean, that expérience is still ambiguous in French between experiment and experience. And also that I was wondering whether by 18th century standards, they would, other people than Du Châtelet would intuitively call certain type of measurements, like the Lapland expedition is often called les mesures, or something like a set of measurements. But it could also be conceptualized as an experiment or an experience or something broader than just a laboratory measurement. And for Jean Richer is more or less the same. The fact of measuring the pendulum can be, reduced to actually just a quantitative act, a measurement, but in the context of what he was doing in Cayenne, it was part of an agenda, an experimental agenda with observation of the stars, tides, and so on and so forth. So maybe there is also an idea, a reference to a broader picture than just the the act of measuring a single phenomenon that authorizes the use of experience to refer to this act of abstraction. But I'm not sure, just how they came to mind.
Yeah, thank you. I think that's ultimately quite helpful, really, as far as linking the idea that we've got hypotheses that are subject to test of some kind or other, and the idea that these measurements are serving to test them.
Yeah. Well, so Ovidio, go ahead.
Yeah, thanks. So this is very rich. I actually have a lot of more technical questions, I guess, but I have, two things which are not super clear for me. So first of all is, this is probably connected to what Henny was asking. So you seem to, at the beginning, at the end of the paper, you seem to kind of assume that Du Châtelet thought that there are basically one way in which experiment, whatever that means, can be used. And that's namely to test theories, right? Or to test hypotheses. And I wonder, why is this taken for granted? So, I mean, does she say this explicitly? Because I'm thinking she could have believed to begin with that, experiments can have multiple roles, multiple usages. You can have more exploratory experiments in which you kind of just want to determine certain possible links between phenomena, or you can have more, the types of experiment which involve making things more precise and just establishing the minutest possible links between two quantities. So I was wondering why you take the experiments to be just the kind of crucial experiment, right? Of like just deciding between two incompatible alternatives.
Yeah. So she does not, to my recollection, make any explicit claim like that. She is concerned to tell us exactly how it is that she understands the notion of hypothesis, but I don't know that she is anywhere concerned to tell us exactly how she understands the notion of experiment. Now, the organization of the book, this bears some discussing perhaps. It begins with a chapter on the first principles of all our knowledge, which is where she does very explicitly discuss the PSR, and then uses that to prove the existence of God. And there's this sort of more traditional metaphysical material than at the very beginning. That's followed by her chapters on space and time, but then right in there is the discussion on hypotheses, and that all comes before she gets into what you might call the physics proper, where she discusses the elements of bodies, the laws of motion, and then onto particular physical phenomena. And it's certainly a kind of distinctive position of hers that hypotheses have an important use, and in fact, even that they're necessary, right? So given that she has this, as it were, agenda of establishing the importance and in some cases need for hypotheses in science, I see that as to some extent structuring the later discussion, so that, when an experiment comes in, there is some hypothesis that's at stake there. But it certainly is a good project for me to see if there is any discussion of experiments that maybe rises to a more explicit level where we do see them as playing one of these other roles.
Yes, please, Ovidio.
Yeah, just following up a bit, I think. So at the beginning, I think at pages, second page, I think it was, I cannot find it now. Anyway, the point, so you were saying something like Du Châtelet kind of tests the assumption, or whatever that is, that the gravity is kind of uniform, right, throughout the surface of the Earth. And you know, if you have the pendulum experiments, that can basically disprove this and show that, you know, this assumption is not true and so on. But I was wondering if you see a difference between framing it like this or framing it like, no. So essentially what happens is that the pendulum experiments just decides between two kind of incompatible hypotheses, namely the fact that the Earth is like an oblate or a prolate, so a flattened sphere or an oblong one, right? So do you think there's a difference between, you know, a kind of experiment proving an assumption wrong, or a kind of experiment just, you know, being the kind of razor you need to choose between two alternatives and that's it? So I'm just using the experiment to say this is probably true and this is definitely not true, or not that the world is such and such, or that there is this assumption which is definitely false. Yeah, this is pretty vague. Sorry, but yeah. What I have in mind is that if she thinks an experiment can kind of prove the logical impossibility, let's say, of an assumption, or whether experiments kind of are used to decide between alternative theories or alternative hypotheses, which have been traditionally put forward to explain phenomena, such was in this case the two possibilities of the shape of the Earth.
So let's see. So those are different cases because if we're just talking about you have one hypothesis and it gets ruled out, that doesn't structure the subsequent development by leaving another hypothesis in play. That's one difference there. And then also when you talk about choosing between two different theories, it seems like we're not building in here that either of them is getting decisively refuted. Maybe we're just finding some reason to. So that's yeah, so there's a couple of ways that would be different, right? Yeah, well, when it comes to the shape of the Earth, it seems like it's a bit messy, because, you know, we can measure the strength of surface gravity. We also have the geodetic surveying results. And there's going to be also partly an issue of integrating all of that. And that's actually, by the time you get to Clairaut's theorem, it is the way that the problem arises, is that the measurement of surface gravity is taken by pendulums. That is not what it would have to be in light of the geodetic surveying results. So again, it gets quite complicated because there are these very different sources of evidence that are then being reconciled with each other. And to that extent, it could be that I'm maybe overstating the role of the pendulum. It has a very important role, but it's not, you know, not the only thing. Yeah, so we have something like this this phenomenon, I suppose, in that the results of the Lapland expedition do seem to decisively rule out the Cassini, let's call it a hypothesis, right, of the prolate spheroid. But they're still leaving both the Newton and the Huygens alternative in play to some extent. The measured values are closer to Newton's than to Huygens, but then they end up at the end of the day raising this problem for Newton. So maybe that might be a way in which we see experiment playing both of those roles. So maybe the role of just ruling out the Cassini theory, and on the other hand, giving us some reason to prefer Newton's, but certainly this is not decisive proof, not least because of the Clairaut problems. So maybe her discussion does incorporate those different factors. And yeah, so maybe it does call for, in my paper, a more nuanced discussion of the role.
If Ovidius is again a follow-up, I guess you can keep it going. Otherwise, Annie.
No, it's not.
And is any your intervention a follow-up?
Yes and no.
But you came first, like you raised your hand first. So if none is a follow-up, then Annie.
Yeah, it's about the footnote at page 31. So it's footnote 48. So I wondered, so there you explained that Newton only accepted Richet's measurements, but you also mentioned that he, where I'm looking for the passage. So he corrected the length of the pendulum to account for the difference in temperature between the equator and Paris, making Richet's value agree with that for uniform density. And then you end the footnote, Newton's dismissal of all the measurements except Richet's may have led Du Châtelet to single out Richet's as incontestable. And so there's a kind of tension here, I think, because if Newton, on the one hand, can dismiss most pendulum measurements, and he corrects also Richet's measurements to fit his own assumptions, well, can we still say that this pendulum case illustrates the kind of hypothesis testing that Du Châtelet advocates? Or could we say that it shows in Newton's case that measurements will become tests only within a certain interpretive framework, and this interpretive framework could already protect the theory from falsification.
Mm-hmm.
And because if Newton adapts the measurements to fit his theory, there's something strange with the incontestability or with the objectivity, so to say, of the measurement.
Mm-hmm. Yes, well, I mean, one thing to point out here is that Du Châtelet herself rejects Newton's correction. So that is, that's apparent in the commentary on the Principia.
Okay.
I don't think she makes that point in Institution. So yes, I mean, by her lights, Newton is not actually making the right use of that observation.
But still, historically, it was seen as a confirmation, I think, no, of Newton's theory. So Du Châtelet was an exception, I think, then, not accepting the, let's say, the manipulations of Newton to make them fit his own theory.
Yeah. Well, so I think yes, that's part of my picture is that she is a bit more probing about this empirical evidence and willing to raise a lot of caveats, which, and there is, I did not try to get into this in this paper, but there's a very stark contrast with Voltaire. His treatment is a lot more superficial. So sorry, let's see. There's something I was going to say to that. Oh, yeah. So with the reason that he needs to apply that temperature correction in particular is to make the results compatible with his assumption of uniform density. And Newton takes on board, and this is reflected in Du Châtelet's discussion as well, that assumption is not secure, and so he talks about the ways in which the values will be different if that is different. I'm not totally sure I understand everything that's going on there, but one thing I took away from that is perhaps that he wants to hold on to that assumption partly to make the calculations tractable. And by that, by those lights, it is permissible, I suppose, to say, let's work with these observations while trying to hold on to that assumption to sort of get the whole theory going, and then we can go back and see how we might have to change things. So that might make his procedure look a little more rigorous than just if you talk about applying the correction. But yeah, no, it's a good point. And the broader philosophical issue there is, of course, whenever we're putatively comparing an observation with some particular hypothesis, we do have to take account of these other background assumptions too, absolutely.
Thank you.
So, Vidyu, please.
Yeah, so I would like to ask you something about the discussion on hypothesis as innovation and invention, right? So what you're saying is basically that, Du Châtelet says that hypotheses are a way to, are necessary for invention. And of course, this sounds weird because you would say that, whenever you invent something, you first have to be creative in order to make that happen, right? And there is this weird ambiguity between the clearing the path that leads to a truth, which implies that the truths are already there, and the whole creativity part. But I wonder if could this be just a matter of kind of a discipline matter, a matter of words, so to speak? So what I mean is, could she mean like invention in the very, I don't know how to say it, in the very art of discourse rhetorics type? So, the first thing you do when you make a discourse is the first stage is the invention stage, in which you kind of gather arguments. And in this sense, invention would be basically coming up with possibilities. And if you come up with lots of possibilities, then of course, some of the possibilities can suggest other possibilities and so on. And in this way, it would make sense for her to claim that, this art of invention, these hypotheses are part of the art of invention, are necessary to invention. And the exact reason is that they sometimes just suggest new experiments just because you explore possibilities and you kind of, carve them out, as it were. I mean, could this be a source? Just, good old-fashioned theory of rhetoric, really? I don't know.
Yeah, that's a really interesting possibility. Off the top of my head, I do not know what familiarity Du Châtelet had with that literature. If anyone does know, please, by all means, speak up. This is, I think this is similar to a point that Peter Anstey, I think I mentioned, he's a co-editor of this volume, and he's seen a draft. And he also suggested, when she speaks of hypotheses as serving the purposes of invention, she mentions it in this context of the art of invention. Peter was suggesting to me that that phrase has a fairly specific meaning in this tradition, and that's not something I had actually been very mindful of. Is it appropriate? Do you have any particular references that
I could think of something, but not at this moment, not now.
Sure.
But I mean, just general literature on dialectics generally. So she would surely be acquainted with some version of that, right? So The point being, how to defend X claim, and you have to come up with arguments, and there are like all sorts of procedures of doing this, from, I don't know, Cicero to Quintilian and so on. I mean, there's definitely some sort of literature with which she would have been acquainted to. Of course, I'm just speculating here. I'm not sure what she would actually follow as a textbook or anything like that. But this was still, I think, in the 18th century, this was still a big part of the curriculum, right? The whole dialectics business, as it were. So yeah, so I'm gonna think about it and maybe just follow up with a possible reference.
That would be fantastic. Yeah, thank you. Yes, this would be very good to look into.
Yes, some people are more experienced than I am in this matter, but with respect to what Ovidio was saying, I guess that rather than the Latin tradition, it might be the Leibnizian one. I mean, Lullism, the ars inveniendi, ars combinatori, and so on. And I think that also Wolff in certain texts, but it's been years I've not read that stuff. But I remember a historical commentary on Wolff's philosophy by this Italian scholar Campo. It's like a two-tome, and he dedicates a lot of pages to Wolff on ars inveniendi. But I mean, the early papers that Wolff published, the more Leibnizian ones, and I mean, since Du Châtelet was familiar with these traditions, I guess that that might be one of the lines, the historical lines, if she actually means what Ovidio was suggesting, in that invention recalls this, like the historical invention. But this is, I don't know to which extent this is accurate. And I had, my question was a separate one. So
No,
I might just go.
sorry, that's great though, because yes, we certainly know. I mean, I guess there's some question exactly how much of Wolff's corpus she was familiar with, but obviously he was a source, generally speaking. Yes, thank you.
So one thing that, I mean, it's not been brought up in the discussion yet, but I wanted to say, I mean, it's not really your point because you're relying on George Smith's ideas in that particular point. So page 31 and following ones. But still, I'd like to say I'm not very much convinced of this statement that you quote literally from Smith. So the opposition to the Principia on the continent was almost entirely philosophical. First, because I don't understand exactly what philosophical means here. And if it means that it was not, I mean, conducted by savants, or, I mean, if it's a matter of figures or expertise of like people carrying out opposition to Newton, I don't think it's true. And if it's a matter of disciplines of kind of objections, I also think that it's questionable. I mean, so this is not entirely clear to me. And I mean, it looks like a simplification of what was going on. And same thing for what comes after, the difference between, I mean, I realize this is not they're not your words, but since you're quoting them, the difference between Huygens and Newton, the figure of the Earth, as highlighted in Maupertuis's monograph on the shape of the Earth, of the stars, triggered a shift in the attitude towards the Principia. So this is a very old story, but I don't think it's entirely accurate. So I don't know what you think in that respect, but I'm not entirely convinced of these statements.
Thank you. Yeah. So I think, so it's entirely right to notice that philosophical there is fairly anachronistic. And I think George is using it in that context just to mean not empirical. So, and of course, this, I think, I was a little worried about this because I know that George's understanding of how Newton brings experience to bear is absolutely crucial to his understanding of the Principia and to its reception. And it wouldn't really surprise me maybe if his take would turn out to be maybe a little bit simpler than the actual story. But what I think the best way to make out what he is claiming there is that up until the 1730s, the arguments against the Principia were just in terms of the, one could say maybe conceptual or methodological acceptability. And certainly, the assumption of universal gravitation without bringing to bear any particular empirical results. And so that's supposed to be the thing that shifts. And I would really like to hear more about the way in which maybe we do already see some of that before Maupertuis's 1732 work.
What I was thinking is that, I mean, that the 1732 work by Maupertuis does not really add anything, non-philosophical, anything empirical to the discussion. It is supposed to reopen it and to raise the awareness of the problem in French culture. But actually, I think that Greenberg's book on the shape of the Earth shows it quite well, that you have papers at the presented at the Paris Academy in the 1710s and 20s, where they actually discuss the behavior of pendulums, so Richet's experiments. They discuss the shape of the Earth. I can think of a very, very long Dortus de Méran paper. I think it is from 1723 or something. But Greenberg has a section on that in the book, where it tries to reconcile the elongated shape of the Earth with the behavior of pendulums, with a far-fetched theory of gravity, but really tries to make sense of this evidence. And on the other hand, you have all the people like Cassini and others discussing astronomical problems raised by Newton, for instance, observations of comets and other empirical data, and seeing whether they could reconcile those like new empirical data with Cartesian vortices, or whether attraction sanctioned the end of the Cartesian system. And this is, it's of course partly philosophical, but you have empirical evidence, like new empirical evidence, which is brought in the discussion. And but with respect to like pendulums and the shape of the Earth, of course, 1737, 38 are the dates where like new evidence is brought. From Lapland and so on and so forth. So I don't really see this like 1732 as so decisive a year for the debate. There is a continuity from Newton and Huygens up to Lapland. And so in one way, it is not, it doesn't mark this continuity because there were discussions, and on the other end, it does not really add anything substantial because it will be added later. So yeah, this is my take.
Okay, yeah, one little point. I think I may have misrepresented George a little bit if I suggested that he thought in that book Maupertuis is himself producing any new empirical results. He put the point more in terms of Maupertuis framing this issue as one that's apt for empirical resolution. But even so, what you've suggested is that was in place before. So yes, good. I will look more into all of that.
Yeah, Maupertuis is the first to endorse the Newtonian perspective in France, so that was the. But I haven't read this 2022 George Smith's paper, so I will perhaps read it and then see if I find anything interesting or questionable in it.
Oh, yes, it would be great to know what you think.
Is there any other comment or question? Ah, yes, please, Karin. You're
Yes.
still...
Yeah, okay. Yes, yeah, I had a more general question. So I realize this is a commentary, yes, and intended to make the learned public aware of new developments, especially as regards these experiments. And in while reading the text, I sometimes ask myself the question, well, to what extent is Du Châtelet's position original compared to those of others? Of course, it's clear that she disagrees with various figures, including Newton and also partly with Huygens, but I cannot really tell whether others had raised similar worries in relation to Newton or Huygens or others. And so whether she was simply summarizing criticisms that had already been raised. And now I see that this chapter is, it has a particular purpose. But even so, for me as an outsider, I was asking myself this question. And so I know that Du Châtelet is considered to have important and innovative contributions. And I guess this is particularly true of her institution. But I was wondering if this is also true of the commentary, and if yeah, if not, then what exactly is the added value of her work? Yes, for us, yes, because if it's one of the, or maybe the best compilation of results, of recent results and recent debates, um, um, is it more worthwhile than maybe comparable reports? I don't know if there were any. Yes, but I guess you get the idea of my question.
Yeah, I think so. So what George Smith brings out is partly that she was writing at a very particular stage. So in contrast to what maybe we could think of as the first wave of expositions of Newton's thought, Caille and I don't know, de Sagoulet, maybe I guess he's a little later, Stravesand. There's been empirical research that's done since their work, so that that for people who are just looking for a conspectus of developments, they're not going to find. There's been a couple of decades since those works, right? And that's not there.
Yeah.
And there is some of that in the so-called Jesuit edition of the Principia, in the annotations there. But that project was completed, I think, 1741, 1742. And by the time Du Châtelet is writing her commentary beginning 1745, there's already some new results to incorporate. So that's not really so relevant to the case I'm focusing on of the shape of the Earth. The other stuff is more or less, I guess, contemporaneous with that Jesuit edition. But for the commentary as a whole, and especially looking at some of the astronomical work, some of that, there wasn't anyone else that was writing at that point in time. So that's
okay, but
one main thing
maybe
there. Yeah.
maybe with regard to specific points, yes. So if she is critical of Newton, yes, or of Huygens or of others, are these her own original criticisms, or is she in that regard also just drawing on other publications? Yes, maybe not in full-length commentaries, but is she just picking up on what had already been put forward by others? So I think that if the answer is no, yes, that if some of her criticisms are original, then I think that it might have been nice for the reader to realize this, yes, where she is drawing on accepted criticisms, and where she is advancing her own. Yes, I do not know if this is very relevant to the commentary, but yeah, she gets a whole chapter in a book, and then I would like to know, where she moves beyond opinions that had been put forward by others.
Okay, yeah, that's perfectly fair. And I guess it does seem to me that we don't really see much of her original philosophical position in the commentary, just because of the nature of the work.
Yeah.
So yeah, from the point of view of what her original contributions are, the thing to bring out for me, I hope, is just how the commentary illuminates what she says in Institution, where we do get a more original position.
And so, can you give an example of that, of how the commentary? Do you mean the commentary more generally, or also your specific contribution on the use of pendulums?
Oh no, sorry, I meant the commentary as this separate work.
Okay.
Yeah.
Yeah.
Of
Yeah.
course.
Yeah. Okay. Thank you.
Okay, is there any other question or comment, especially from those who haven't asked a question yet?
Well, I wanted to make sure that I say thanks. This has been extremely interesting and extremely helpful.
Well, if there is no other question or comment, well, we thank you for this very nice presentation and discussion. And we hope to read the final product of your research soon, this paper and then the book on Du Châtelet soon. So please join me in thanking Katherine once more, and all the best and good luck with the further stages of this research and this paper.
Marco, can I say something? A bit of advertisement for another online event next week on Thursday, where Pier Paolo Betti is going to discuss Kant and his indebtedness to Du Châtelet as regards his early response to Newton. So that's on Thursday, 5 to 7, and Aaron Wells is going to give a response. So you're very welcome to join.
Oh, terrific.
Katherine, I'll send you the link, yeah, so you don't have to worry. Okay.
Great, thank you.
Okay, that's it.
Thank you very much, Katherine, for this.
Bye.
Thank you very much, Katherine. Bye.
Thank you.